Hello everyone, welcome to another question by Martin Tutorials. Let's pretend we're in the manufacturing industry and together we're making different types of containers. We are given an assignment to produce cylinders. There's a cylinder and we are told they must have a fixed volume of 500 centimeters cubed. Given that fixed volume, we need to minimize the surface area to minimize cost, as all parts of that container cost the same of that cylinder. So what would the dimensions be? The height and the radius to minimize the surface area of this cylinder. A quick reminder, I have two YouTubes, Martin Tutorials, which is only mathematics, and Variety and Fun Math, which is all fun topics. Both are free to subscribe and both come with a full money back guarantee. And now let's tackle this question. To save money, we want to minimize the surface area. As it's minimizing, I'm pretty sure we'll use calculus. So with calculus, I'll make an equation where the subject of the formula is whatever I need to minimize or maximize. In this case, it would be minimize. So I let that S represent surface area. And now we need a formula for surface area. With a cylinder, the surface area is the circles, the bottom and the top, and the surrounding area. Remember, in a three-dimensional shape, surface area is all the sides added together. A circle is pi r squared. So we've got the bottom pi r squared, the top pi r squared. That's 2 pi r squared. And the surrounding area is that circumference multiplied by height. It's 2 pi r times h. And so that's our formula for the surface area of a cylinder. I would like to do the derivative, except we have more than one variable. We need to find an equation that relates r and h, so I can do away with one of those variables. And one way to find that equation is I say to myself, if we have to minimize the surface area, why don't we just make everything 0? We cannot do that because we are told the volume has to be 500 centimeters cubed. So we're going to use that to link r and h. Volume is pi r squared h. 500 equals pi r squared h. We divide each side by pi r squared. H equals 500 over pi r squared. And we can plug that into the equation. So surface area equals 2 pi r squared, that stays the same, plus 2 pi r, in a bracket, 500 over pi r squared. That replaced the h. And now we simplify. The 2 pi r squared stays the same. 500 times 2 is 1000. Pi's cancel out. R divided by r squared is 1 over r. I write it as r to the minus 1. It's easier for doing derivatives. Now that we have only r, it's derivative time. I use the notation ds over dr. That can vary depending on your course or instructor. I obviously suggest you do the way your instructor tells you. All right, rules of derivatives. They bring it to the front. It's 4 pi r. That's exponent 1 less. Minus 1 brought to the front. That exponent is reduced by 1, becomes minus 2. So ds over dr, the derivative is 4 pi r minus 1000 r to the minus 2. And now we set that derivative to 0 to solve for r, for the value that minimizes surface area. And I rewrote that r to the minus 2 as r squared underneath. There's many correct ways. And to simplify, I multiply through by r squared. So 4 pi r becomes 4 pi r cubed. And if I multiply through by r squared, that just becomes minus 1000. I can multiply through by r squared as it's equal to 0. And I now want to solve for r. First step, I'm going to solve for r cubed. Once I solve for r cubed, then we solve for r. So I'll bring that minus 1000 to the other side. I like to keep my equal signs in line. So 4 pi r cubed equals 1,000. Divide each side by 4 pi. R cubed equals 1,000 over 4 pi. And divide top and bottom by 4 equals 250 over pi. So r cubed equals 250 over pi. Now I want to isolate that r. I power each side by a third. That'll just give me that r. And what I do to the left, I do to the right. So r equals 250 over pi, all to the power of a third. See, that's the r to the 3 to the third disappears, and this bracket, the third, is what I said, 250 over pi to a third. And to work this out, I used my calculator. I was very careful. I said 250 divided by pi equals, and then I powered it to 3 inverted, or 1 over 3, to make sure this whole bracket is the power of a third. And with a calculator, it came out to 4.301, which I've made it just one decimal point, which is 4.3. Now that we have r, we need to solve for h. I need an equation that relates r and h. It's a volume equation. Volume equals pi r squared h. We told volume is 500. We solved for r as 4.3. So 500 equals pi times 4.3 squared. That's r squared times h. To solve for h, we divide each side by pi times 4.3 squared. And I did that very carefully with a calculator. And h equals 8.6. And the answer to the question, radius is 4.3 centimeters. Height is 8.6 centimeters. That's to 1 decimal point. And I noticed that height is double that of radius. Interesting. And thank you all for watching.